Hello everyone, this is Ashish and welcome back to our podcast. Today we are going to have a solo one again. A lot of things going on. My book is coming out based on my experience of working in BARC and ISRO, and my seminars are coming out. So I have talked about it briefly before as well. The tickets for the seminar, if you want to meet us, our team, and the talk community in person and be part of that 4 hour long discussion kind of thing. Well, a lot of people also have been asking me, like, what is this seminar about? The seminar is not about any particular thing. The seminars in general are always kind of like a meetup. You join over there, you'll have the freedom to ask question anytime, like have a discussion, talk with me, talk with other people, and it's think about it like a gathering. So it's a fun event, limited number of people. It's not like 400 people stacked in a hall. It's not like that. We are going to have a good time. You're going to have a person to person discussion with me. Obviously there will be a stage kind of thing so that I'll be able to address, but it's mostly like I'll be roaming around talking to you guys about a particular thing that also might be from you. Like, generally how it goes is that someone asks a question and I start a discussion, and we become part of an experience, and the discussion keeps on going in the direction that we as a team in that hall leads it, kind of. So it's a very different kind of experience, and I would like for you to experience it as well, first person. The last time I did it was in 2019. I did 2 sets in 2019. I did it twice in Chennai, twice in Mumbai, and then once in Delhi, Delhi, Bangalore, and Ranchi, one time each. So it's going to be a great experience. And somehow or the other, if you can join it, I would say don't miss the experience, because we do not know when is the next time it is going to happen. The last time it happened, it was 4 years ago. Other than that, very excited about the book coming out. I have disclosed the title, I have disclosed the thumbnail now. Sorry, not the thumbnail. I've disclosed the cover. Much more complicated than a thumbnail, and I've talked about what the book is about. I am not going to talk about what the book is about in this podcast, because I've done plenty and more will be done in some other one. Although I will be talking in detail about me being a writer, what it was like to write that book for 5 years, what was the process, the journey, how patient I had to be, and how I redrafted that book 11 times to finally get it to the stage of publishing. Maybe I'll talk about the stages of publishing as well. Few of the young writers have been approaching me of how to publish a book. I have an idea, I've been writing, I love writing, and how to publish a book. So even to those people who are not interested in writing, it would be like a task that you do simultaneously for a long time that gives you big results. And also to those who are aspiring, it might give you a direction. Other than that, I always love to know what you want to know, so let me know down in the comment section. A bigger topic of discussion today would be the Chandrayaan-3. And the last time they did a Chandrayaan, that was Chandrayaan-2, and that was in 2019. And at that time I was a scientist at Indian Space Research Organization, a full-fledged one as well. I still remember the night at which they were going to have the moon landing of Chandrayaan-2. I was actually on a bus returning from Sriharikota, which is the launch pad of ISRO. We were working at that point in some GSLV Mark II launch that was going to take place next year early, which never happened that early because COVID pandemic happened, and ultimately the F-11 launch, I think that was the launch vehicle that we are working on, happened significantly like 6-7 months later. I don't remember the exact date, but that's what I was returning from. Like, our team, I was in the engine team. I was working in earth storable rocket engines. To those who are not from technical background, even from the propulsion background, understand that the fuel that is used in those rocket engines are liquid in room temperature, and also those kind of engines you'll see everywhere. You saw it in the launch of this Chandrayaan-3, which to be more specific was done with GSLV Mark 3. Mark 3 has a twin Vikas engine, and these fire right after the S-200 fires on the ground level. It fires a little bit above the ground, but still like well inside the atmosphere of Earth. So I don't want to get too technical too fast, and also I do not want to like bring facts about Chandrayaan-3. Okay, there's differences between Chandrayaan-2 and Chandrayaan-3, because truth be told, I've not done that much specific research on this. If that is going to be the case where I'm going to be talking about it specifically, I'll have to make a video which is like well edited and well scripted, and let me know if you are interested in that kind of video. But right now I just want to have a friendly discussion, like a brotherly discussion. Think of me like your elder brother. I want to, or your younger brother who used to be a scientist at ISRO, and you'd like to know, hey Ashish, yeah, you used to work over there, right bro? So what was it all about? And what's this? Like, explain, why is there a fire over here? Why is the stage, what is the stage itself? Like, in a basic manner, I want to explain what this whole mission is about, right? And also what might have been the reasons of impartial success of Chandrayaan-2. Like, that's the thing, like ISRO always says that it is 90% success of Chandrayaan-2, but truth be told, they wanted to have a soft landing on moon, and that did not happen. Although their orbiter is still functioning, it is working successfully. It worked successfully, sent back a lot of data from moon, but the soft landing never happened, and we can't call it 100% success, because that's what they did in 2008, which was Chandrayaan-1. So the main ambition with any of the subsequent Chandrayaan would be to have a soft landing, and that's a difficult task, because you might think that the gravity of moon is just 1/6 the gravity of Earth, but it is still a lot. All right, it's still a lot, and it becomes difficult to land in a very soft and gentle manner. Above all, moon saved Earth from a lot of meteorites, otherwise they would have fallen right on us. So it fell on moon and left a lot of craters. And another thing would be like Earth has an atmosphere, right? So a lot of meteors burn, and moon does not have an atmosphere, any significant one, so it crashes right on the surface of the moon. So whatever meteors fell on moon, they left a lot of craters, and then it's a very difficult terrain to have a landing, and that too on the southern pole of moon. It is a very, very difficult task, no doubt. And if you're talking about any kind of space mission, the first thing that you accept are failures, right? There are so many failures, right? It's only that ISRO has had so less failures that you always want it to be a success. But this is the reality of space industry. There are much more. It's not even just fair to say more failures. It's significantly much more failures than success. I mean, just to look at the Apollo missions, look at any kind of mission that even the Soviets did, they've always faced more failures, right? And that's when you know that a space organization is actually matured, because if it is succeeding every time, it is most likely just replicating what other space programs or what other countries have done. But when it has started failing, that's when you understand, oh, it's trying to do something new. Because copying a technology is easy, right? But building a new technology, obviously it will involve a lot of failures. And that's what kind of happened in Chandrayaan-2. It was not a disastrous failure. Like, there have been a lot of disastrous failure in space industry as well. Like, the launch vehicle explodes on the launch pad, and that's the worst case scenario. So when I was in ISRO, there was a ISRO induction training program in which, like, it is a 3-month training program. You're basically being paid a monthly proper salary to sit in classrooms and being taught by top senior scientists, like people who have won Padma Bhushan awards and those who have retired like 10 years ago. But ISRO scientists never retire. Most of them, they move forward to work in other domains. For example, I've known ISRO scientists who have retired 5 years ago, and they are working closely with Kerala government and being a technical advisor to the chief minister. I've seen others, for example, few went out and started working for Skyroot, which is the private space organization, one of the very few of India, and a lot of them ended up being like kind of consultant, because the kind of experience they have for 35 years working in that industry, and only in the last phases they kind of understand everything, right? And that's when they retire. But you can always be like an advisor, right? And they keep on working closely, not only just with ISRO, but with DRDO, with BARC, and maybe with HAL, and other industries where their expertise would be very much demanded, right? Man, there's so many domains. Like they can be working with institutes, they can be working with like something that you can't even think about. Like for example, a scientist who has worked in cryogenic engines of Indian Space Research Organization might find a second resort in RRCAT Indore, which is also working in cryogenic technology, but closely aligned with nuclear science, because it is a part of Department of Atomic Energy. So, well, you see, this is the beauty of our podcast. We just go unscripted, but your brother is talking to you, so I hope you're enjoying. So that's the kind of thing that I want to do. I want it to be like a conversation that you enjoy and get to know scientific stuff over here. So what I'm going to do is, first of all, compare the timelines of Chandrayaan-2 and Chandrayaan-3, and it is very similar, right? So they launched it in July 2019, Chandrayaan-2, and this time in July 2023 they launched Chandrayaan-3. What is the exact reason for that? Well, when it comes to orbital mechanics, a lot of things comes into the play, like when are these two celestial bodies the closest. For example, you might have watched that movie Mission Mangal, right? And if you watched that movie, you know that they are talking about a thin bracket, a narrow bracket that they get to launch it. That's where Earth and Mars are in the closest range, so that they invest the least amount of energy. And in a similar manner, I do not know the perfect orbital mechanics, but all of these orbits, none of them are circular, right? They're all elliptical orbits. So when it comes to two elliptical orbits, there will be a narrow bracket. Maybe you'll get two, maybe you'll get only one. Depends. For that, you'll have to study both the orbits of Earth and Moon. Here, the orbit of Earth does not matter as much, because Moon is orbiting Earth itself. But well, you'll need to get into orbital mechanics, and people who are working with space science and engineering, one domain itself, like there is a department in Indian Space Research Organization, which I think is something trajectory mechanics something, right? And if I remember correctly, it is in VSSC. So what they do is talk about trajectory all day, and it is again a very deep science and orbital mechanics, and like to high school people, even if you have studied physics till that point, you'll think about Kepler's law and all as just the basic idea, but they are going to move in that direction, and it's another very complicated topic. So coming back again, when you look at the orbit of Moon, you'll understand that okay, there would be a particular time you should be launching, but another reason why they are doing it in July might be that August 15th is the Independence Day, and they would like to do something patriotic somewhere close to that. Now let us go and see the timeline of Chandrayaan-2 and compare it to the timeline of Chandrayaan-3. So what I'm going to do is I'm going to use total 4 website pages. Number 1, Wikipedia page of Chandrayaan-2, Wikipedia page of Chandrayaan-3, the ISRO website page of Chandrayaan-2, and the ISRO website page of Chandrayaan-3. Over here, as you can see, this is the Chandrayaan-2. So you'll see that there are a lot of dates, and the events, if you look at it, it just says that first orbit raising, second orbit raising, third orbit raising. So it's like you cannot blame a lot of people to think that you launch a rocket and it lands on Moon, right? It's a straight path, you go over there. But the thing is, the way that we move on Earth, like if you have to go to the grocery store and the grocery store is straight ahead of you, you drive your car straight, right? And when you're looking at, oh, Moon is there, Earth is there, so I'm going to drive my rocket straight. But that's not how it works, because when you're talking about gigantic celestial bodies and compare that with the small spacecrafts that you have, then the gravitational influence is humongous, and it is going to be extremely difficult for any spacecraft, and we are going to say spacecraft and not rockets, because spacecraft would be the ultimate payload which is going to move through space and time, and that's going to traverse through space. Okay, so you can think about Chandrayaan-3 as a spacecraft as it looks on the screen right now, right? And this is something that is going to actually reach the moon, and this is the payload of the GSLV Mark III launch that you saw, and all of that effort, tons and tons of energy for just this payload, right? And this payload is not directly go to moon in a straight path. It is going to orbit Earth multiple times, and what we are trying to do is kind of get away from the gravitational field of Earth, right? And the getting away from gravitational field of Earth is extremely difficult. And even this is what people don't understand, right? Because they see astronauts flying, right? If you look at videos from International Space Station and the astronauts that go over there, and they're just floating around, right? And you think that, oh, they have just escaped gravity and now there's no gravity over them. But that's not true, because what is really going on is that you are now in a gravitational influence which is giving you a revolution around the Earth. Basically, if you want to think about it, you are in a free fall, right? So let us say I throw you off a 10-storied building. I won't, but let's say I did. When you're falling, and I'm saying when you're falling, in between, let us say you're parallel to the 5th floor right now, can you fall again? That's not possible, right? When you're falling, you're already pulled towards the Earth with a gravitational force, and the acceleration is 9.81 meter per second. That's the G term you might have used in your physics numericals, right? So you're pulled towards the Earth, but you cannot be further pulled, right? So let us say you are falling in the 5th floor and I hold you in the 5th floor and somehow throw you again. That's not going to happen, right? So if you're falling, right? And your acceleration towards the Earth is not going to change. You're going to fall at the same rate. Now think about, you're falling, but you kind of miss the surface of Earth. Now this is a little bit difficult to visualize, especially when you're just listening to the podcast, but I throw a cannon, right? I throw a cannon and I shoot a cannon and it hits the Earth. But what if it misses the Earth, right? I'll try to show it with the figure for those people who are watching it on the video platforms. So what if it misses the Earth? If it misses the Earth, it is still in the gravitation. It wants to have a revolution. And that's what is happening with all the satellites. That's what's happening with the moon itself. So they are all under the influence of the gravity of Earth, right? So it's wrong to say that there's no gravity in the outer space. You have not escaped the gravity of Earth until you have gone for interplanetary missions, right? So the only time ISRO has sent anything man-made which has left the gravity of Earth is during the Mars orbital mission, because now you're getting into the gravitational field of Mars. And if you want to get to that point, you have to leave the gravitational field of Earth. And that's what we call escape velocity of Earth. I'm going to put a number over here. It's close to 11 kilometer per second. And this is the velocity with which you need to launch something from the surface of the Earth. Keep that in mind. Where you are going to launch an object with what velocity is very important. So if you're on the surface of Earth, you launch with escape velocity of surface of Earth, you're going to leave the gravitational field of the Earth. So you are not having any gravity anymore. Now, that's the thing. Even if you leave the gravitational field of Earth, you are still under the gravitational field of Sun, because Earth is under the gravitational field of Sun. So there's another escape velocity, which is the escape velocity from the surface of Earth to leave the gravitational field of Sun. Now, if you launch a body from the surface of Earth with this velocity, you will for sure leave the gravitational field of Sun and you leave the solar system. Now, this escape velocity will be different if you're on Earth. This will be different if you're on Mercury, and for sure it will be different if you're on Sun. surface itself. I do not know how you're going to do it, but if you are on the surface of sun, that would be the escape velocity of needed to escape the gravitational field of sun. And that would again be different if you're at the center of sun, right? Now, even if you leave the escape velocity of sun, are you free? You can go anywhere? No, you're still under the gravitational pull of the Milky Way galaxy. So a lot of people don't know this, but sun itself is not stationary. Sun itself is having a revolution around the center of the galaxy. And for us, that is the Milky Way galaxy. And what is at the center of Milky Way galaxy? Well, there's a black hole. And that black hole is the most preposterous amount of gravitational field that is in our galaxy. And that pulls not only the sun, but all the other stars that you see in the night sky. And they're all having a revolution around this black hole. So even sun is not independent of an external gravitational force, and it is not stationary. So you think that, oh, Earth's revolution is like this around the sun, but it's actually sun itself moving. So Earth's revolution is a spiral around the center of the Milky Way galaxy. Well, we were about to talk about Chandrayaan, but well, this is what we used to do in Spacecast. We used to talk about this stuff all the time. And I told you, like, I'm going to do Spacecast on our podcast from now on. So here you go. And because of the unscripted nature, you will have discussion. Because what I want to do all the time is explain everything to you as if you do not know anything. So the moment I'm going to say something which you might not know, I'm going to talk around that, right? And I hope that you love this part of our podcast. So this is all about the gravity. So Chandrayaan has not escaped the gravitational field of Earth, and Moon is also in the gravitational field of Earth. It's only that when it comes close to Moon, it now also has the gravitational effect from Moon, which is significantly lower than the gravitational field of Earth. But as when it is about to land on Moon, it is much closer to Moon as compared to Earth now. Now the gravitational field of Moon is more dominant. And that's when it enters the gravitational field of Moon, and now it starts an orbit around the Moon, right? So our objective for Chandrayaan-3 over here would be to reach higher and higher orbit of Earth so that it ultimately touches the gravitational field of Moon, gets caught by it, and starts having an orbit around Moon. You get my point? So that is why you can't have a straight path. Like if you want to have a straight as an arrow line between Earth and Moon, the amount of energy that you are going to need is going to be monstrous. It's not even physically possible. By the way, you might not know this, but if Earth was even like 10% larger than it is, like naturally, let us say if it was, you were never going to leave the surface of Earth. Did you know that? Because then the gravitational pull of the Earth would be a little bit larger, and well, it would have been so difficult. Because you know the problem with launch vehicles, and this is like the mass energy balance that all of the launch vehicle designers, and when I say launch vehicles, to the layman term, think about it like a rocket, right? A rocket is a layman term. In the space industry, everybody calls it launch vehicle. At least in the space organization that I work, that is ISRO, they used to call it launch vehicle. So it is always a complicated design because, well, I want power to leave the surface of Earth so that I reach an orbit around Earth. That is, let us say, our first target right now. I want to launch a satellite, so I want to be in a free fall situation, so I want to enter an orbit, right? We are going to talk about bigger orbits later. For that, I want to put a lot of energy down below, right? It's basically just Newton's third law, push and go up, right? When you're in space, it's more conservation of linear momentum than Newton's third law, but we are not going to get into detail. If you want to know more, I'm going to put some videos that I made a long time ago down in the description box. You can go through it. It's mostly about moon landing and the 3 misconceptions of space science and engineering. All right, so basically for layman term, you can say that I'm going to push against the earth, so I'm going to have an explosion. And this explosion, by the way, ladies and gentlemen, is measured in gigawatts, right? The power plants that you're talking about, thermal power plants, nuclear power plants, their energy is like 500 megawatts. But these launch vehicles, all of a sudden, an explosion of gigawatts happens on the surface and just throws whatever is on top of that explosion away from the surface of Earth. So this energy is a problem, because if you want more energy, you'll have to have more fuel. And what is going to give more fuel? The one which is causing an explosion. So if you are having more fuel, you are having more weight. So if you're having more weight, you'll need more fuel. And if you're having more fuel, you'll need more weight to be lifted. So it's a very complicated science that rocket scientists have to always work around to find that weight of fuel that will just balance and throw it with the velocity and acceleration. So it's difficult to have a launch vehicle which actually reaches the orbit, basically. So that's why they say it's how difficult can it be? It's not rocket science, right? Rocket science is really the most complicated science that you can think of in the history of science of human beings. All right. So what we are trying to do over here is reach an orbit and then raise that orbit, right? Now we want to reach closer and closer to the gravitational effect of moon. So over here, you can see that when it comes to Chandrayaan-2, they did a launch on 22nd July. Then around 2 days later, they did their first orbit raising maneuver. So like I said, any of these orbit, when an object is influenced by another gigantic celestial body, is going to be an ellipse. This is actually one of the Kepler's law. Some of you guys might remember studying this in middle school. So it is going to be an ellipse. And that means that it is going to have 2 centers. Ellipse has 2 centers. And one of these centers is going to be the object around which it is having the ellipse, or around which it is revolving. Now, that means that if you look at this ellipse, the object will be at one point closest to the object around which it is revolving. At the one point, it would be farthest. And that closest point is called periapsis, and the farthest point is called apoapsis. For Earth, it is going to be perigee and apogee. For Moon, it will be perilune, apolune. There are other terminologies. But basically, there will be one closest point and one farthest point. Now, what I want to do is basically raise the farthest point, right? So that it ultimately reaches Moon. It gets caught in that Moon's gravitational field and creates an orbit around Moon. So I'm going to fire rocket engines at periapsis so that my apoapsis raises. So what we are basically doing is adding energy to the orbit. And if you are going to add energy at the closest point, the farthest point is going to increase. That's where the physics that you see on the surface of Earth is going to be far different than the physics that you see in orbital mechanics. Because in Earth, what happens is that if you want to have a turn, you are going to turn right away. If you want to go faster, then you are going to accelerate. But over here, if you are going to go faster, or if you want to go further, then you have to put energy a little bit ahead of time, right? So if you're going to fire engine when you're pointing this way, you're not going to go this way. The thing is that you are in a revolution. So you fire an engine when you're going like this, but you are obviously going to go in an elliptical orbit, and all that is going to happen is that ellipse is going to become larger. Or you can think about it like the major axis is going to become larger and larger. I'm going to do my best to add as many visual images or videos that I can so that you understand it the best. But even if you're just listening, maybe you will be able to understand. Let me know down in the comment section how much you are able to understand. But I'm trying to break it down to the 7th and 8th standard physics so that everybody gets an idea. And there are a lot of people, like you might be a banker and you want to know, hey, what is this Chandrayaan all about? I want to know a little bit more, right? And that's my whole objective. So there will be couple of burns to raise the orbit, right? So as you can see, 22nd July 2019 to 13th of August 2019, these are all maneuvers, and on 13th of August it is trans-lunar injection, right? So this is what I'm talking about. This is where it gets caught by the gravitational field of moon. And then now our objective is to reduce the orbit, right? So earlier, to leave Earth and get caught in the gravitational field of moon, I want to raise the orbit. But when I'm caught by the gravitational field of moon, I want to drop the orbit, get closer to the moon. And ultimately, what is going to happen is your orbit is going to shrink down to a parabola. And that parabola is going to be how you are going to fall on moon or land on moon. And that's where it gets complicated, because you need to now start thrusting some energy on moon in the downward direction so that your acceleration towards the moon is very, very low. So you're talking about like a gentle soft landing, right? And that's very complicated. I think that's where the problem was created, because one of these thrusters did not work properly. So let us say you are having 4 thrusters and one does not work properly, then you are having an unsymmetric distribution of force. So you're having a tilting, and the moment it starts tilting, now it is much more difficult to get it back. So it is going to tilt, turn, and it is going to fall in a way that it was not supposed to. But later on, NASA released the fragments that was seen on the surface of moon of Chandrayaan-2, and there were so many that a lot of people start thinking that it was like a crash landing. Like I still remember, like I said, right, I was on bus and Komal was on phone, and she was saying that and we were both watching it on YouTube, the live telecast, and just like I would say 5 to 10 minutes before, about 5 minutes, I don't remember properly, before they actually said that it did not work, I already knew it did not work. It was written on their faces. I'm sure that I was not the only one who recognized that, right? Because they lost signal couple of minutes before they actually, like, the landing was supposed to happen. So they lost signal. I don't know why. Maybe there are aliens over there. Hey, right. So Americans knows about podcasts more than Indians do, I guess. The delivery guy knows that I'm doing a podcast, so that's good. Now, maybe he'll subscribe to my channel too. Let's go. Where were we? So yeah, so it has to be a very soft kind of landing, and right, nobody properly knows exactly what went wrong, right? And that's also like a country's responsibility to keep it secret kind of thing, right? Okay. Yeah, I'm having a telephonic consultancy call right after this, and it's getting hot over here, now hotter that I have taken off my jacket. And we are going to have a continuation of this in next podcast, maybe talk more about Chandrayaan-2. You see, I'm not only just talking about Chandrayaan-2, we are talking about basically space science and engineering, learning that in the most basic manner, but also I'm talking about Chandrayaan-2 and Chandrayaan-3, right? So my objective over here, at least after the middle part of where I was discussing, has not been 100% like talk about Chandrayaan-3, but mostly like how these missions work, right? We are going to break it over here and talk more about it in the next one, because I want your feedback as well. Like, did you like this part of the podcast, and were you able to understand? Even if you are not from that much of a scientific background, very few people have actually got an experience of working in space science and engineering. So I definitely am not expecting. I know this because before I joined ISRO, and even like 6 months after I joined ISRO, I was not able to understand any of these. But I started understanding, and I actually learned much more after leaving ISRO because I got a lot of time to study. ISRO gave me a very well defined trajectory of what I need to study, where I need to study from, and helped me a lot to learn. I'm going to start discussing about my book after this. I'm definitely going to put on a shirt, otherwise, man, I feel bad about other people who is so jealous of my fine physique. I'm just kidding, man. I'm going to put a shirt so that I'm more confident. It's not very comfortable for me either. But I'm having a telephonic consultancy. I'm going to talk to a gentleman, and then after an hour, I'm going to continue recording this because we have a few things to talk about the book. See you soon. You're going to actually see me after a second. I don't know why I said that, but be back. Fucking stop that. All right, we are back over here, like I promised, back in a second. Now, even though it is just a second for you, it was an hour for me. And that hour led me to think that ISRO is going to have a certain amount of time before they have hopefully a soft landing on moon. And in that, it will go through different phases. Like we talked, it is going to have the orbital maneuver firing, the LAM engines firing, and then it is going to have a translunar injection, and then it is going to have firing again to decrease its apoapsis this time, and finally have a soft landing. And in all of those phases, I would like to talk what's going on when it comes to orbital mechanics and space science and engineering, so that anybody can understand, right? Anybody who wants to understand should be able to understand. Every science should be broken down into 8 standard physics and mathematics, just as it was supposed to be. And if you can't explain it simpler, you do not understand it well enough. Something along that line, wise words by Albert Einstein. So if I am not able to explain it to anybody who is not even from science background, then I don't understand well enough myself. So it's a tough test for me as well, and I'll try to pass that test. So let me know down in the comment section your hopes and ambitions for the upcoming art podcast, which will have a spacecast segment. So what we basically did in the first half of this art podcast was full-blown spacecast. You check out those 11 or 12 episodes of spacecast that I published on Ashish Ranjan channel, and this is all that it is. And if you loved that first part, man, go and binge watch all of those spacecast episodes. All right, now in other news, we are going to have gotta remove this hat, should not be a hindrance to your vision. All right, so I want to talk a little bit about my journey of becoming a writer. And now I can say that I'm an author because I have my first book coming out. And it took me 5 years to write this book, but it mainly took me 5 years to become a writer, because now in the subsequent books that I'm going to write, I'm pretty sure it's going to be an easier task, because now I know how you put forward a plot, how you introduce the characters. So there has been a lot of hit and trial. Like this book that I wrote, The Boy Who Did Not Sign, ultimately needed me to do 12 different drafts. Now that's not very common, right? Most likely authors are supposed to do like 4 or 5 drafts and that's it. But I needed to do it so many times because I was not able to make so many connections, and also I was super paranoid of making this book perfect. and because it is highly inspired by my personal story. So I mean, yeah, you put your story forward, you better make it sure that it's perfect, right? And also, like I did not know a lot of things about how the publishing industry itself works. So now I do, and it will be easier in the next ones. And I just want to share my whole journey of how it all happened, the phases of it, right? So believe it or not, for the past 5 years, every day I've been sitting at least like 3 hours to a maximum of like 12 hours writing. It's a complete different art form where you are creating worlds in your head and putting it down in words, and you want to give your readers an experience. And it is also extremely difficult when you don't have readers, right? Like when people are not going to read your book, because how are they going to read it until unless you have published it, and you have never published anything before? So how are you going to know how they are going to respond? So that's going to be a first timer for me as well. So first time writers, they always take like 3 years, 4 years, 7 years. I think Amish Tripathi took somewhere around 7 years to publish his first book. So yeah, it's pretty common. But it's a process that I would like to share. So I was young at that time. I'm still young, but I was a young scientist at Indian Space Research Organization. And till that time, I had no experience writing. Like the most I would have written was a Facebook status. That's it, or some one paragraph on some community post or kind of things like that. But when I was writing my interview experience, my ISRO interview experience on Quora, that's when I found that I have a knack for it. Like I have a knack to share emotions and experiences in a way that's not only depicting information, but is also telling a story. And who doesn't love story, right? There's a big reason I picked this career is because everybody loves story. And this is what I used to talk a lot in art of speaking as well, that everybody loves story. There's only two things that everybody loves. Number one, story. Number two, humor. And this is something that you will learn if you do any kind of public speaking as well. Like the class can go numb and the hall and audience can go sleepy, and the moment you crack a joke, everybody is wide awake. The moment you start telling a story, everybody is wide awake. So I knew this. I knew that I was kind of having a talent in it, interest at least, and so let's write something. And that's when the whole process started, and it was precisely 17th of August 2018, on the day I gave my ISRO interview. And that's where I was sitting on a local bus, red color. They call it Lal Dibba in Maharashtra, at least in the Mumbai area. I was sitting in the last seat. You know, when you enter a bus and you're out of luck, that's the seat you sit in. And it was jumpy and bumpy, and I did not care much in that 4-hour journey. I was going to Alibag because I was posted in heavy water board, and Alibag was the closest plant from Mumbai. And we were sent over there, a couple of boys who were freshly joined. We were sent over there to get some training in heavy water production. And after the interview, I was returning back to Alibag, and that was like the 4-hour long journey, and I did not feel any of it because that's where I got lost in writing. And that's what I've heard Mark Mason say as well. Like a lot of people come to them and say that how do you keep on writing so much? Because the one thing about writer that you must have is that you should not have any problem of writing the same paragraph 10 times. That's what you cannot afford to have. Like you cannot afford to have a problem with that, because that's the whole process of writing. You have to write it again and again and again, find the tiniest of mistake and best way to depict a particular idea, philosophy, emotion, story, whatever it might be. And that's what I found over there, that I love writing. And then I was just not that serious. I mean, I still remember that in 2019 December, I was out with some friends in Pondicherry, and we were just having a good time, and I was telling them, hey, I'm writing a book. So I was taking it seriously, like I am going to write a book. I never knew that it was going to take 5 long years. I still remember then I had a trip in Goa. So I had a lot of trips, man. After I cracked ISRO examination, I had so much fun. I have to tell you this, because this is one thing that you are going to see with Ashwin Taksh all the time in the book, is that he never has any vacation. He does not go for trips. He does not enjoy his college life, all because he just is always focused on some goal, some target or the other, and believes that I have to sacrifice everything if I want this. I cannot let anyone have the tiniest advantage. If I'm going to make it, I cannot enjoy it all when I know that my competition might be working. So that was my mentality. And throughout like 4 years of college, I was in Sikkim, and Sikkim is the tourist place. It's a tourist hub, and there's so many places to go, such pretty girls, man. You want to socialize as much as possible, but I avoided all of them. just because every Saturday and Sunday I would be thinking, hey, I need to invest some more time towards like gate preparation, towards something else, towards being a topper in the first couple of semesters, in the later semesters, towards cracking this gate examination. At that time my aim was to get into IIT Bombay for my masters. And especially like I went so crazy, man. There used to be these holidays, like 7 days holidays of Holi, Diwali, Dashera, Christmas and all that. There were two basic holidays, right? So one was like in middle of a semester, right? So it would generally be like a Diwali, and people go home for like 5 days and they come back to college. And then there would be a bigger holiday session after a semester, right, in between two semesters, and that would be like 7 days to 14 days or so. You'll call it like semester break. And I used to stay in my college hostel all of those holidays. I did not used to go back home, and that is nuts, man. Because if you have ever seen a college hostel during these semester breaks, they are ghost towns, man. Nobody's over there. It is really haunted. There's nobody over there. There's supposed to be 100 people over there. There are like 2 people over there, right? And most likely the other person is having like backs and is over there to clear some subjects that he or she failed, right? So I did not used to go back home because I knew that I'm not going to I was like, I'm not going to waste traveling time. At home nobody is able to study more than 5 hours. I'm going to stay over here and I'm going to put everything. I don't think that is like really healthy. All right. And see, that is why I like to talk about general things, because when you start talking about something, there's always ideas of what I can talk about. So I remember few of the followers or subscribers putting this in the comment section, that sometimes I feel bad when I see other people partying and having a good time, right? And what should I do? Like, for example, this is a good example, right? And Diwali, when everybody else is enjoying, and Holi, when everybody else is enjoying, why would you stay in a ghost haunted kind of ghost town hostel where there's nobody, and you're living alone, right? Isolated for like 7 days. That creates a psychopath, man. Don't know why I did it, but I did it. But that's like the most extreme. Like, I'm a pretty extreme guy, man. The kind of shit that I've done, when you start reading the book, you'll understand that this guy is nuts. All right. But that was like pure extreme, right? Pure extreme. But even to some level, everybody feels that. Like, even on the weekends, you will see others having a good time, right? And they're forming a group. They're going out for a dinner, and maybe in that group there's a girl that you like and you want to join so that you get closer to that girl. But then you are like, I need to study because I did not study well in 11th and 12th, so I'm not in a great college. So if I don't study again, then it's all going downhill in the future as well. So you'll say you're in a dilemma, right? Do I go over there? If I go over there, I waste 2 hours at least, and I also waste money, but I get closer to that girl. And if I don't go over there, I save my money and I also study a little bit, but nothing happens with that girl, right? And I'm always taking example of a guy, because that's what I am. All right. So girls, please change the genders and stuff like that. All right. So you're in a dilemma, right? And let's say you chose that I'm going to sit down and study, right? And then you are having this FOMO, right? That, oh, they are having a good time. This is college life, bro. What am I doing with my college life? So that's the question a lot of you guys might be having, and it's not only stuck to college life. Like, employees have it, I mean working professionals have it. Like, even if you are having a job, if you want a better job, you want to go abroad, things like that, start your own, then you have to utilize every last second, and you have to utilize the weekends and the after hours. I made a video a couple of years ago, like weekends and after hours makes all the difference, right? And it really does. And if you do not use your weekends and holidays, one thing is for sure, you're going to stay where you are, for sure. Like, if you are only working to sustain what you have, then why will you have anything more? So it's always like a mental clash. You are always having a dilemma in your head, like, what do I do? And even if you do the right thing, which is the right thing, like if you're investing for a better future, it is a right thing. Like a better future takes time, it takes effort, and above all, it takes sacrifices. But if you're doing the right thing, then also you're having these questions, right? And that's what I'm going to solve. So I've always thought of it in terms of two different ideas, right? And in the book, you are going to see these two ideas, but never really explained, right? And when I explain it right now, and when you read the book, you'll say, oh, this is what he was talking about. So number one idea is that you decide where you're going to party. And whenever you are going to party, that's where you are going to stay, and that's where you are going to continue to party. All right. So for example, I grew up in Ranchi, right? And then I did not study well throughout my high school, throughout my school life, and then I reached an mediocre kind of college. Okay, did not perform well in ITJ or any of those competitive examinations, so I got like an average to below average college. Now, if I decide to party in this college, have a great time, one thing is for sure, I'm not going to get into a better college for my master's, let us say, or for my higher studies, or I'm not going to get a great job. So next, whatever I'm going to get is either going to be at the same level or worse. So maybe I'll party over there, right? But if I don't party right now and utilize my time into building something better, then I'm at a better stage, right? Now you can now, let us say, come to an agreement or say that I'm satisfied with it, and then you party. All right, let's say you don't enjoy your college life, but you worked hard, cracked it, get into IT Bombay for your masters, and you decided to have a good time. You started spending time in fests, and now you started to have a good time, right? So that's good, but you're not going to get any better. For sure, you're not going to get into MIT, let us say, for a PhD after this, because you have to put every last effort into building something better, and building something better always demands sacrifices. So in a similar case for me, I did not enjoy in college, and then I got into BARC, which is like a second chance to college. I did not enjoy over there. But then I got into ISRO and I started to enjoy, right? Then I went on all the trips that I missed. I went after all the girls that I wanted to, and did everything that I wanted to. All right. And that's the thing. But even after that, I was like, after some point, right? So that's the phase that I'm talking about. So I got into ISRO October 2018, and then did trips after trips after trips. And then somewhere around like February or March, I started to accept like how long it is going to go. So what are we going to do next? And then I took a hard pause and again started the ruthless of utilizing every weekend and after hours, right? And that's when you start to see Talk 4712 picking up, and all the weekends mostly went into like seminars or making videos or like studying more and more things about space science and engineering, gathering more information. A lot of overtimes, for sure. There were a lot of overtime for ISRO, but whatever time I could get other than that was invested towards establishing my own brand, my own website, my YouTube channel, things like that. And for you, you have to decide when you're going to party. But wherever you're going to party, at that point you don't grow. All right, when you're enjoying, you don't move forward, and that does not mean you should not enjoy, right? You should have a good time, all right, but at that time you're not growing. And like I said, like after the ISRO times, like after cracking ISRO and after becoming a scientist in ISRO, I spent like 3 months having a great time. But then I got back and then I started growing again. So that's like a delicate balance dance that we all do, and you should come in agreement with that. This is how the world works, and unfortunately this is how the world works, because it would be great if we would be having a good time at the same time growing as well. Some people are good at doing that, but for sure if you're having a great tremendous time and getting shit-faced drunk, you're not growing as much as you can, and that hurts you too. Like, I'm not using my full potential, and that certainly hurts as well. And the second concept is about don't make home at the place that you want to live. Now, a lot of you guys might be getting an idea of what I'm going to talk about, and this is the exact line written in Boyo Did Not Sign. but it's never properly explained. Like there's like few lines before this, and that's how I wanted to write this book, right? It should not be everything self-explained. I'm explaining it like you know nothing. A book should be in a way that you are able to read in between the lines, and you make your own ideas, you make your own imaginations, and you think what's going to happen according to yourself. And I'm going to talk about don't make home at the place that you want to leave maybe in the next one, but I'm going to end this podcast over here. Let me know what you think down in the comment section. Highly technical in the first half, highly philosophical in the second half. Let me know which one was your favorite, and we are going to run it again very soon. The book is going to be soon out. The tickets for the seminar are out. Go to ashishtalk.com. You'll get all the information. I hope to see you in one of the seminars, Mumbai, Delhi, Chennai, and Bangalore, maybe in some other cities as well. Keep up on ashishtalk.com and you'll get the updates. But register for the tickets if you are available in a particular city where the tickets are open, because tickets are selling fast. And I hope to see you over there in the seminar. That's about it. I hope you're going to read the book, and I'll see all of you in the next one. Till then, bye.